This is a video for section 4.3. We're going to talk about coterminal angles today. And we're also going to get into some parts of the unit circle based on the conversations we had last time. So, terms and parts of angles. The beginning position of the ray is called the initial side. And that is right here. And for us, on the vast majority of the time, our initial side is going to be 0 on the unit circle. And it's rotated about its endpoint, and the endpoint is called the vertex. The final position of that angle, or the second ray that makes up the angle, is called the terminal side. And the terminal side is a big idea for us today. We're really going to focus in on this terminal side. Alright, the measure of an angle is the number that describes the amount of rotation from initial to terminal. And we draw these arrows from the initial side to the terminal side, and that gives us the measure of the angle. And we want to make sure we understand that direction matters. So, when we talk about positive angle measures, alright, they're generated by rotating counterclockwise. If we talk about negative angles, they're generated by rotating clockwise. So keep that in mind. Positive angles go to the left, negative angles go down and to the left. Positive up, negative down. Standard position of measure of angles, and this is where, when we just said our initial side is always 0, if we're considering things in terms of the unit circle, it's always on the x-axis. And then, as stated before, if I open up, I have a positive angle measure. If I open down, I have a negative angle measure. But my initial side is always this first side here, the x-axis. So, two angles in this expanded angle measure system can have the same initial side and the same terminal side, yet have different measures. So, we call these angles coterminal. Co meaning together, terminal, so it means they have together have the same terminal side. So the first question we have is find and draw a positive angle and a negative angle that are coterminal with the given angle. So my example, 30 degrees. If I look at the unit circle, or I think about the unit circle, 30 degrees happens somewhere about here. And if I were to label that, it would look like this. 30 degrees. But I need to draw a positive angle and a negative angle that are going to end up in the same place. So if I think about drawing my negative angle, alright, remember, here was my terminal side. I want to understand, and you do have to draw your arrows so that we understand which way we're going, that if I start at 0 and I go down, I went down negative 330 degrees because I went down and around. That's my negative angle. To figure out a positive angle, to go along the same thing, I'm going to start at 0, but I can't use 30. 30 is the angle I'm given. I need to draw another positive angle. So to get another one, if I start at 30 and I go around, and I come back around to my terminal side, I've traveled 360 degrees plus 30 more. So my coterminal angle is 390 degrees. So these would be my two answers. Okay? Now, keep in mind, it's a circle. So I can spin around and around and around and around. So could I go more than one rotation around the circle? Yes. But every time I go a rotation, I need to consider that I have gone at least 360 degrees. Or if we're talking about things in terms of radians, I went 2 pi to get a full rotation. So our second example is in radians. Negative 2 pi over 3 radians. 2 pi over 3 is equivalent to 120 degrees. So instead of going 120 degrees up, because of the negative, I go 120 degrees down, which gets me to negative 2 pi over 3. So now I need to draw my two angles that are coterminal to this. So I know my angle's down here. Well, if I go in the positive direction, I find that I have gone 240 degrees, or 4 pi over 3 radians for my first angle. For my second angle, remember, I gotta go positive or negative. So the question asks me to give a positive and a negative, so this time I gotta go negative, go past, all the way around once, and here I am, and I end up at negative 480 degrees, which is also negative 8 pi over 3. And keep in mind, 2 pi is my whole time around. So when I'm trying to figure out my radians, if I add 2 pi, or negative 2 pi in this case, because I went down to negative 2 pi over 3, it'll actually, my calculator will give me the answer of negative 8 pi over 3. So here are 2 student examples. Please pause the video, attempt the questions, and come back and check your answers. Go ahead and check your answers. It's very important to make sure you think about drawing your picture when you're doing these. It's helpful. It's also helpful to have your unit circle sitting out next to you so you can kind of figure out where's 150, where would negative 150 be. Makes things a little bit easier as you work through them. Now, evaluating trig functions determined by a point in the first quadrant. So let theta be the acute angle in standard position whose terminal side contains the point 53. So the first thing I have to do is figure out where the point 53 is. So go over 5, up 3. Here's my point. Draw my line. Hey, now I have an angle. But the question is, find the 6 trig functions of theta. So here is my theta, and I can draw an altitude straight down to the x-axis that gives me a triangle. Well, I know, based on my triangle, that my opposite side is 3, my adjacent side is 5. So I'm going to have to find my hypotenuse. So 3 squared plus 5 squared equals c squared. I end up with 9 plus 25, which is 34. So c is the square root of 34. Well, now find your trig functions. Remember, I have sine theta, cosine theta, tan theta. Do not forget your theta. A couple of us missed some points on our quiz because we did not put theta in its correct spot. And now that I have all my labels on my triangle, go ahead and fill in your functions. Remember, I cannot leave a square root in the denominator, so this becomes 3 square roots of 34 over 34. Cosine is 5 over the square root of 34, so that becomes 5 square roots of 34 over 34. Tan is opposite over adjacent, so 3 over 5, which makes cotan 5 over 3. If I do my reciprocals, secant is the square root of 34 over 5, and cosecant is the square root of 34 over 3. And there's my 6 trig functions. You will want to make sure you draw your picture so you know where your triangle is located, because it will matter with your side lengths. In this case, both of our sides were positive, so that didn't make a big difference, but if I have a negative, I also have to take that into consideration. Now, notice your student example contains a negative 2. Make sure you use that negative 2. Go ahead and pause the video, draw your picture, answer the question, and come back and check your answers. Go ahead and check your answers. Notice, as you were working these problems, that, for instance, secant has negative 2 in it. So does cosine. So does tan and cotan. So, because we are in this second quadrant, we need to talk about things in terms of that negative 2. Please make sure you label things appropriately. Now, evaluating trig functions. So find the 6 trig functions of 315 degrees. Alright, so first I would once again go back and draw my picture. I know 315 degrees is here. If I start at 0, I go this way, I know I traveled 315 degrees. We need to use what's called a reference triangle though. So we always draw our triangle up to the x-axis. This gives me my 90-degree angle. Well, I need to figure out what this theta is. What's this angle in the middle? Because that acute angle is the angle that I'm going to use to discuss my 6 trig functions. So if 360 is all the way around, I only went 315. That means that that theta has to equal 45 degrees. Alright. Well, I know from last class that if theta is 45 degrees, I have a 45, 45, 90 triangle. Which tells me that, based on our special right triangles in the unit circle, both of my sides have length 1. So I have 1 here and 1 here, which 1 squared plus 1 squared is c squared. I know that this is the square root of 2. 2 equals c squared. If I square root that, I come up with c equals square root of 2. Now that I have my sides, go ahead and do your 6 trig functions. Remember, now I'm not putting theta in there though, I'm putting in 315 degrees. It always goes with the angle. Now if you recall, before we get started here, we went over 1, which is positive, but then we went down 1 to get to 315 degrees. It's in quadrant number 4, so this one here should actually be negative 1. Alright. So, my opposite side, adjacent, hypotenuse, opposite is negative 1 over square root of 2. If I rationalize that, I get negative square root of 2 over 2. Cosine is 1 over the square root of 2, which is positive square root of 2 over 2. Tan is opposite over adjacent, so negative 1 over 1, which is negative 1. Cotan is the reciprocal of that, so 1 over negative 1, which is still negative 1. Let's make this look a little better. Alright, secant is the reciprocal, so it's the square root of 2 over 1, which is just the square root of 2. And cosecant is square root of 2 over negative 1, which is negative square root of 2. And there are my 6 trig functions. Make sure you draw your picture so you know which quadrant you are talking about. Right? Next thing we need to do is talk about how do I evaluate some of these trig functions without a calculator. Well, I need to use my unit circle. And in order to use my unit circle, I need to understand that when I'm evaluating a trig function without a calculator, I'm looking for the coordinate. Where is that point along the outside of the unit circle? So when I do this, any x coordinate goes with cosine. Y coordinates go with sine. So x is cosine, y is sine. So if I'm looking for the cosine of something, I'm looking for the x coordinate at that point. If I'm looking for the sine of something, I'm looking for the y coordinate at that point. I also need to understand some properties. For instance, tan is sine over cosine. Cotan is cosine over sine because it's the reciprocal. Cosecant is the reciprocal of sine, so it's 1 over sine, and secant is the reciprocal of cosine, so it's 1 over cosine. Because my unit circle only gives me things in points, and because those points correspond to cosine and sine, I have to be able to change my other functions to write them in terms of sine and cosine. So let's attempt one. Here we have the sine of negative 210 degrees. So I take a look at my unit circle, and I start going around negative 210. Well, if I go positive 210, I end up over here, which means if I go negative 210, I should end up over here. So here is my negative 210 degrees. I'm looking for the sine at negative 210 degrees. Sine, remember, is y. So the y value at negative 210 degrees equals 1/2. So the sine of negative 210 is 1/2. Remember, we looked for where would our angle be on the unit circle, then sine is y, so I looked for the y coordinate. Now, sines and cosines are nice because all I have to do is look for that specific coordinate. Sine is y, cosine is x. But when I start talking about tangent, things are a little different. So remember that the tangent is the same as the sine of 5 pi over 3 over the cosine of 5 pi over 3. So you're going to have to do a little more work here to figure out your tangents. So 5 pi over 3 happens here. So if I go around, this is where I get to 5 pi over 3. Well, that's this point here. Sine is y, remember? Cosine is x. So this equals negative square root of 3 over 2 over 1/2. Well, I got to do some work. Remember, we can't have all these extra fraction bars, so we have to multiply by the reciprocal. So I'm going to multiply this by 2 over 1 and 2 over 1. These cancel out. On top, my 2's also cancel out. So I end up with negative square root of 3 over 1, which is just negative square root 3. Okay? So the tangent of 5 pi over 3 is negative square root 3. Next thing, I have secant and cotan. Remember, secant is the reciprocal of cosine. So this is 1 over the cosine of negative 3 pi over 4. Well, 3 pi over 4 is up here. Negative 3 pi over 4 is going to end up down here. So here is my negative 3 pi over 4. But I'm talking about the cosine of negative 5 pi over 4. So the cosine is the x-coordinate in this case. So I end up with 1 over negative square root 2 over 2. Well, I have to multiply by the reciprocal. And that leaves me with negative 2 over the square root of 2. But remember, I know I can't leave a root 2 in the denominator. So I get negative 2 square root of 2 over 2. Well, if you recall from before, you can cancel those 2, so I finally end up with just negative square root of 2. Okay. So for our next question, cotan 35 degrees, we're going to move down a little bit. We're talking about the cotan of 135. Remember, that is cosine over sine. So, if I look at where is 135 degrees, it's right here. Okay, so cosine is x, sine is y. So I get negative square root of 2 over 2 over positive square root of 2 over 2. Well, I know that when I have the same thing over itself, it just equals 1. And 1 is negative, 1 is positive, so my answer is negative 1. So it's important to make sure you have your unit circle sitting with you as you work through these so you can take a look at it. Now, here are 2 student examples. Please pause the video now and use your unit circle to check your work. Come back and check them when you're done. Alright, go ahead and check your answers. Make sure if you have any questions that you note those and ask your teacher. Alright. Next set. Evaluating trig functions of quadrantal angles. Angles whose terminal sides lie along one of the coordinate axes are called quadrantal angles because they lie on the quadrant. So, find each of the following if it exists. If the value is undefined, write undefined. So, 270 degrees is normally down here, but we want the sine of 270, negative 270. So we're going this way, 270 degrees, and we end up here. So see how my angle actually ends up on the y-axis. Well, sine is the y-coordinate, so in this case, it's 1. Does it have to be any more than that? No, it does not. So, if I find each of the following, if it exists. Now, these are student examples, but you need to keep in mind that we've gone a little further. For instance, the tangent of 3 pi. We know one trip around the unit circle is 2 pi, so I want a whole nother pi. So we go backwards for just a second so we can look at our unit circle. If I go 3 pi, that means I went, here's 1 pi, 2 pi, 3 pi. So I'm back over here. This is my spot. So notice my point is negative 1, 0. So if we fast forward a second, tangent happens at, negative 1, 0. So remember, the tangent is sine of 3 pi over cosine 3 pi. Well, sine is 0, cosine is negative 1. 0 over negative 1 is 0. So the tangent of 3 pi happens, or is, its value is 0. 11 pi over 2. Okay, remember secant is 1 over cosine. And if we back up again, real quick, remember now we're talking in terms of pi over 2's, and we do 11 of them. And it's in the positive. So, if I start at 0, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that actually ends me up down here at 270 degrees, whose point is 0, negative 1. So remember, this is 0, negative 1. So 1 over the cosine, well, the cosine is 0. Can I do 1 over 0? No, I can't. I cannot divide by 0. So this is undefined. That's why we have that caveat in the directions. It says, if it does not exist, write undefined. So anytime you end up with something that's going to divide by 0, you need to write undefined. Alright. Finally, your homework is page 381, 1 through 9, 25 to 41 odds. Make sure if you have any questions, you stop your teacher and double check so you're on the right track, because we will also have a short turnaround here before our quiz. Okay, thank you.